Right now, somewhere in your life, there's probably a person you can't stop thinking about, or once was. Maybe it's happening to you right now. That specific, slightly irrational feeling where one person's name lights something up in your chest that logic can't quite explain. You call it love, but what's actually happening in your brain during that moment isn't romantic at all. It's ancient biological machinery, and it wasn't built for romance in the first place. Here's the strange part. Anthropologist William Jankowiak studied 166 human societies across history and found clear evidence of romantic love in 89% of them, an almost universal signature across cultures that never had contact with each other. When something shows up that consistently across humanity, scientists don't usually call that a cultural invention. They call it a biological adaptation, something wired into us by evolution, not something we simply learned from movies and love songs. So if it's biological, where did it actually come from? In 2023, researcher Adam Bode published a paper making a case that reframes the entire thing. His argument is that romantic love wasn't built from scratch. It hijacked a much older system already sitting in the mammalian brain, the bond between a mother and her infant. That circuitry, built on the hormone oxytocin, has existed in mammals for tens of millions of years, keeping mothers and babies chemically bonded long enough for the infant to survive. Bode's theory is that evolution eventually repurposed that exact same wiring and pointed it at adult romantic partners instead. Think about what that actually means. The warm, protective, can't stop thinking about them feeling you get for a partner is running through neural circuitry that was originally built for keeping a mother attached to a helpless newborn. You didn't get a new emotion when you fell in love. You got an old one, borrowed and redirected. But romantic love isn't just one system. Researcher Helen Fisher, using brain imaging studies, identified 3 separate biological systems layered on top of each other, each with its own evolutionary job. The first is lust, driven mostly by testosterone and estrogen, whose only real function is pushing you toward mating in general, not toward any specific person. The second is attraction, sometimes called limerence, the intense, obsessive, early-stage infatuation. And the third is attachment, the long-term bond that keeps partners together well after the initial spark fades. The attraction stage is where things get almost uncomfortable once you understand the mechanism. Fisher's brain scans showed that people in early-stage romantic love display activation patterns in the brain's reward circuitry that closely resemble the patterns seen during drug intoxication. Specifically, 2 dopamine-rich regions light up, the same regions involved in addiction and craving. At the same time, serotonin levels actually drop, which helps explain the obsessive, intrusive thinking that makes new love feel so consuming and so hard to reason your way out of, even when your friends are telling you to slow down. From an evolutionary standpoint, this isn't a coincidence or a flaw. Fixating hard on a single partner instead of spreading attention across many candidates was almost certainly a more efficient reproductive strategy. So the brain evolved to make that fixation feel euphoric enough that you'd actually follow through on it. Then comes the third system, attachment. And this is where oxytocin and a related hormone called vasopressin take over. This is the part of love that isn't loud or obsessive. It's steady. It's the reason long-term couples feel calm and secure around each other instead of constantly anxious. And it's built on the same ancient bonding chemistry that mammals have used for parental care since long before primates existed. Some of the clearest evidence for how this system works doesn't even come from humans. It comes from a small rodent called the prairie vole. Prairie voles are one of the rare mammal species that form long-term monogamous pairs, and researchers studying their brains found that the difference between a monogamous vole and its close cousin, a non-monogamous vole species, comes down to how many oxytocin and vasopressin receptors they have in specific reward regions of the brain. More receptors in the right spot, and the animal bonds for life. Fewer receptors, and it doesn't bond at all. It's a genuinely strange thought that scientists can trace part of the biological basis of lifelong loyalty down to receptor density in a rodent's brain, and that humans likely run on a version of the exact same underlying system.
So here's what all of this adds up to. You didn't invent the feeling of falling in love, and it wasn't handed to you by culture, poetry, or Hollywood. It's a repurposed version of the oldest bonding system mammals have, originally built to keep a mother tethered to her infant, later hijacked by evolution and aimed at romantic partners instead. Layered on top of that ancient bond are two more systems, one built purely for craving, wired through the same brain circuitry as addiction, and one built purely for reproduction in the most general biological sense. All three run at once, mostly without your permission, every time you fall for someone. That obsessive, can't eat, can't focus feeling in the early stages of a relationship isn't a personality quirk or a sign that you're especially romantic. It's dopamine and dropping serotonin doing exactly what they evolved to do millions of years before romantic love had a name. And the calm, steady feeling that shows up later, the version of love that doesn't feel like a fever anymore, is oxytocin, quietly running the same program that once kept a mother close to her child, just aimed somewhere new.
Every time you fall in love, some part of you is running code that predates language, predates civilization, predates the idea of romance itself. The feeling is real. It's just borrowed from somewhere much older than you'd expect. If you want to dig deeper into any of this, all the research is linked down in the description.